Monica. I work at the Center for Innovation at Leiden University, and I am also the community manager at XR Era. And yeah, today we decided to do the first sort of joint meetup with media and learning. And of course, we've been working together for a very long time already, but I think this platform is probably more suited than the one we've been using for quite a while. We're going to do quick short introductions for the speakers today, so I'm not going to take up too much time, but afterwards, once we're done the introductions, we're going to do a panel discussion. I have a few questions that I've prepared, but for you, the participants, of course, please feel free to add questions in the chat. That will be Thomas who will be monitoring those. And if there are any questions that he thinks need to be, brought up quickly, then we will stop the panel discussion and bring in your questions, so it's a little bit more interactive. Yes, so let's start. Who is going to start? Well, I think Neil, you're the first one to go.
Super, thank you. Hopefully you can hear me and see my slides. Yeah, I'm delighted to be here. I think this is a topic dear to my heart, so I'll crack on. I am Dr. Neil McDonnell. I'm a philosopher at the University of Glasgow, but I ended up taking an awful lot of different roles in respect of the adoption and the proliferation of XR across the university in research and teaching. I'll speak a bit about teaching today. I come from industry before my academic career, and that has informed how I see the interaction between industry, that is developers in particular, and teachers. So I'll say a few things today about how I think you can bridge that gap, I think, in line with the workshop's theme. So on the academic side of things, what we did is we ran a teaching competition quite early, maybe 2017, where I asked teachers what they would do with the XR technology if their wishes were to come real. And the idea was that we're trying to extract the enthusiasm and excitement out of colleagues who had just recently seen VR and capture that excitement, capture those ideas that came from them. Not all of the ideas were practical. Some of them were a bit too haptic dependent and such like, so they didn't maybe work. We had to do some level of sifting. But then the trick was really to try and get the academic side to think through in baby steps, in microscopic steps, what the user journey was for their students. From the moment they walked into the room with their jacket on to the moment that they walked back out again, I wanted to know every individual step that they would take, and not just into VR, do a task and out again. We needed detail. What button do they press? What do they look at? Where does their instruction come from? What can the teacher see? And so on. So thinking through that user journey in baby steps showed us some things that were more problematic than others, and it allowed our staff to fully understand the richness of the possibilities, but the richness, I guess, of the decisions that would need made along the way, because those decisions need communicated clearly to a developer if you're going to get the outcome that you've got in mind. When it came to trying to recruit developers and recruit other companies to want to do this without us having to spend excessively in their direction, and when it came to trying to capture funding for the project that we did, it was really important for our side to be able to understand two kind of commercial things effectively. One was to identify the scope of the potential audience for the experience that had been outlined in this kind of ideas process. And that would tell us what the size of the market was effectively if we were to sell this on. And then what we had to do is evaluate the cost to the institution of being able to adopt these technologies or this particular teaching intervention. And then on the whole, what we decided was if we build enough of them, we lower that institution cost per incremental one. So if you build a platform, every new thing you put on the platform costs incrementally less. And that was our plan. That was what we split our task into. So from the academic side, you need to get clear on the brief, and you need to be able to articulate, whether it's to your own institution, to funders or developers, what the business case for this proposition looks like. On the industry side, I think it's really important that you sense check what the academics are telling you, right, that they want XR to do. Again, the ones that were heavily dependent on haptic experiences or rapid motion or, the usual range of things that kind of trip over users is one dimension of worry. But the other was things that could have been a YouTube video. What you need to do is make sure you match the XR pitch and the XR proposal to the features that are distinctively good about XR, these features and benefits. I think you will need to, developers and commercial companies in general will need to change their mindset from when you deal with a commercial company, you might want to expand the brief to get more things in it and be paid more, frankly, for the job. With academia, it's going to be very hard to get things funded at all. So minimizing the brief actually raises the odds that it'll happen and raises the long-term prospects. So it's a bit of a change of policy there. I would encourage developers to defer to the audience insights of the audience that they're dealing with. I think academia, students in academia are not the same audience as the gamers or consumers or visitors to a museum or whatever else that you might be used to thinking about in terms of your audience. And I think you should listen carefully to the academics and teachers telling you about the norms and expectations, the longer patience you might imagine, the greater technical sort of adeptness over time, because it's not supposed to entertain them, they're supposed to direct their attention to it. The students will bring, rather than Joe Public wanting to play with something, and it's quite a significant difference. A big thing that developers on the commercial side are able to do to get projects to happen at all is to seed the activity with in-kind support. Offer to do a quick demo, offer to do a brief amount of optimization of an object, offer to do very low cost to you things that can seed the funding that universities are much more likely to fund themselves, and funders are much more likely to dispense money if they can see in-kind support or balance or match from industry there. And then when it looks like there might be a commercial prospect here, do not expect a university or academic side to exploit that, to be able to even see it, or to be remotely interested or motivated to go after it. Any individual academics will not be, and institutions are not built to be commercial entities. So when the time comes, be prepared and willing to pick up the commercial baton and run with it. That, in haste, was the headlines I wanted to give between these two sides and how I think you can bridge the gap. The core message really is this: de-risk the practicalities. Right, so de-risk the chance of them getting it wrong by helping them match to XR features. De-risk it with your giving in-kind support and help. De-risk it by making sure they don't make mistakes along the way about the audience that they're going for. That's a message for both sides. And this image is supposed to show how we've tried to de-risk it at the University of Glasgow. We've made centralised resources so that we can share the access to them, so no one application or no one use case bears the costs and the responsibility of being able to support the work. That kind of shared way of dealing with things makes it much more practical. And I'll stop there.
Thank you very much, Neil. Next in line we have Moeezo.
Can you all see my screen?
Yeah, we can see it. It's, however, your entire desktop.
Is that what you're seeing? Not the slides?
I can see the slides and then just the other slide, the tabs at the top as well. So I'm not sure if there's another setting that you need to.
Actually, that's fine. It's going to stay that way.
Okay, good. Okay.
Not too distracting.
No, not at all.
So hi everyone, I'm Moeezo Saleem. I'm an XR software developer. I work at the Center for Academic Innovation at the University of Michigan. So what does the Center for Academic Innovation do? Our main mission is to design the future of learning through research, innovation, experimentation, and iteration. We are working towards educational equity through curricular innovation, building accessible educational technology, and conducting educational research and learning analytics. So we serve the entire University of Michigan community, which includes students, alumni, and faculty. And we also serve global learners and other organizations through our online courses. The Extended Reality Initiative was formed in 2019 within the center with the overall goal to bring XR technologies to the entire campus. The XR initiative has three main goals, which is to integrate XR into residential curricula, to integrate it into the online curricula, and create innovative public-private partnerships. The XR Initiative Fund, the XR Initiative provides an innovation fund to seed XR projects for teaching and learning. And the goal of this fund is to create innovative learning experiences with augmented and virtual reality and to increase access to XR technologies to a broader audience. So far, the XR Initiative has held 2 rounds of funding, and we're in the process of holding a third round. And we've received 34 proposals altogether, and we funded 25 projects. And these projects came from 13 of the 19 schools and colleges that we have here at the university. So in the first round of funding, which happened in 2020, we funded 8 XR projects. And out of those 8, you can see 4 of the projects here, which coincidentally are all VR experiences. And these are the projects that I've been the most involved in as a developer. So my team and I designed and developed these experiences from scratch with the help of faculty who offered the subject matter expertise in most cases. And sometimes they also helped with the direct development of the project. So these projects cover very diverse topics. As you can see, there's a chemotherapy simulation for managing complications for the School of Nursing students and nurses. We have a VR physics lab to teach students principles of projectile motion by launching rockets in different environments. And then we built a nuclear reactor laboratory, which is a virtual reality experience, and it's a virtual replica of a decommissioned nuclear reactor that used to exist on the campus. And this project runs actual reactor simulation, and there are 4 different experiments that students can perform. And then lastly, we have our augmented tectonics project, which is a construction architecture project which teaches how to construct with different types of building materials. So in 2021, we held another round of funding, and this time we asked the faculty to propose projects that did not require a lot of development, but instead they must propose the use of commercial authoring tools. And we provided them the learning experience design and project management support for these projects. When we funded these projects, 3 of them were using HoloLens 2. There was 1 mobile AR project, and then the rest of the 10 projects were all 360-degree interactive videos. And we explored topics such as soft skill development, language learning, exploring nature, and handling difficult situations. So next, I would like to mention some of the amazing and very talented student fellows that we work with. So we hire student fellows every semester to work with us at the XR Initiative in many different roles. So we've had these fellows working as user experience designers, as developers, 3D artists, audio engineers, and project. And these are some of the work that they've done for us, like UX experience work, creating 3D models. And this is just this fun project we did. This is a meta-human you see of our student fellow, Jessica. We created a 3D mesh through a 3D scanning app and then took it into Unreal Engine and converted it into an animated meta-human. And these are photos from the day we all visited an LED stage that we have on campus, which is used for virtual production. This stage is at the Ross School of Business, and we do not manage this stage, but we are currently in the process of getting our own LED stage. So for the meantime, we often collaborate with the Ross School of Business to learn virtual production techniques, and our entire team is skilling up in this area. So this is our virtual diag, which is being used to teach a class which is about XR, and the students are in XR. So we've recreated this. We have diag is like an actual location on campus, and we've recreated this in VR. And we use this space to hold online events here. So this is a brief video, but in the interest of time, I'll skip it. But this is our Senior Director, Jeremy Nelson, who's talking about what we consider the future of learning to be. And I can skip the video and show you. Yeah. So basically, we believe that the future of online learning is to create engaging and immersive content through virtual production techniques. And we're investing in an LED stage to create this immersive content. And so this image is our architecture VR project loaded onto an LED stage. And Jeremy is standing in front of the stage pretending to teach about, because he doesn't really know about this, but he's pretending to teach about wood preparation process for construction. And then you can see that there's a front plate in front of him. It's also animated, and he can hold objects and observe them from all dimensions as he's teaching about them. So this is a zoomed out photograph of one LED stage. Again, it's not our stage, but it's just to give you an idea of what the facility looks like. And you can see that another nuclear reactor project that we worked on is loaded onto this stage. And you can see like it has two walls and a floor. And when you're looking at from this zoomed out perspective, it doesn't look quite right. But when it's shooting through the camera, the perspective is, you get the correct 3D perspective. So lastly, I would like to mention that we've partnered with Coursera to produce 10 XR-enhanced online courses, which are focused on the future of work. And we've identified 4 categories of extended reality that we can use in these online courses. And these are interactive 360 videos, which are more accessible through browsers or on laptop or mobile. And then there's mobile AR, which is, again, more accessible to people. And virtual production, which even though it requires high-end XR equipment to produce, but the end result is just a video. And then we're also exploring how we can bring immersive VR content to a wider audience, which is a challenge, and we're still learning about this. So yes, thank you so much. This is our contact information, if you want to grab that.
Thank you for that. Lots of questions, I'm sure. Next up is Mikhail.
All right. Hello, everyone. Let me share. Okay, so my name is Mikhail Fominykh. I work as a researcher at the Norwegian University of Science and Technology and a couple more organizations, but I'm focusing on the academic part of my life today. So we are the biggest and the only technical university in Norway. And here, I have a title of developing an XR apps at the university lab as an overall umbrella. And I will say a few words of who we are, what we do, and some considerations and rather questions that we could discuss today. So we are a research group on working on innovative immersive technologies for learning. So we have a cross-disciplinary focus, XR and learning or education as the second area of interest, and we focus on designing and innovating and not only on the research part. And we structure our activities along the 3 main pillars of exploration, education, and experimentation. We started 5 or 6 years ago with just mostly doing the explorative work, exploring ourselves and working on raising awareness among the university staff, local organizations, visitors from companies, public organizations, government departments, and so on. And of course, majority of our visitors were students and staff from the university. And what we mostly did, we tried to show people what XR is, what virtual augmented reality hardware there is, what kind of applications and features and affordances these technologies have. In parallel, we had a couple of R&D projects, few student projects that we used mostly to showcase what these technologies are and what they can do. Over time, we started to run regular public one-day conference events with some invited speakers and with an extensive demonstration part term. And yeah, over 1 or 2 or 3 maybe years, we've gathered a network or a group of people who would come because there is an event on a topic they're interested, and they would use us as a point of expertise where they could consult about XR. And in case of their ideas on XR being progressing, they would come to us with their ideas, and these ideas that they would have turned, for example, into new joint proposals for research and development projects, or they could, in some cases, turn into smaller pilots that we could assign students working on their projects. And then we became somewhat a hub between students, local companies, different departments at the university, all interested in or having at least some interest or curiosity about XR. And then it took us some time, but over the years, it sort of grew up into quite a good-sized research group and a lab with a good number of projects as well. Large and small internal university projects, locally Norwegian funded, Norway funded projects, and international projects. So in the educate component, we started with supervising some student projects, and then this activity grew up into several more systematic teaching activities, and we now run courses both for IT and design students on XR development, and also for the potential users or the target audiences, those people who don't have the technical skills or don't need that much of the technical skills to develop XR, but those who need some skills to actually use or introduce XR into their organizations. So both type of these courses are quite popular. And then the experimentation part is our research development and project activities. I can now show you a little bit of the organization in the project, and these are the activities that I manage in this research group. Is that we have some R&D projects, and we try to connect them to student projects. Sometimes we start with a student project and students developing and delivering a prototype that seems very promising, and we are able to continue working with the subject matter experts whom we employed for that project or with whom we collaborated, and then we can grow this into a bigger R&D project, getting some external funding, or vice versa. When we get these larger projects, we try to separate certain tasks there, and both research and development tasks, to give them to our students or student teams. So this goes back and forth all the time. And what's became a good solution to us is to an important factor in succeeding in this was to apply agile software development methodologies and managing the cooperation between project partners, organizations, and our students, and also our subject matter experts, and keeping the code and basically running the research projects as they are software development projects. And we're now also doing this even with single student projects, always keeping in mind that this could grow into something much bigger. So we are trying to strictly follow all the agile software development processes. Of course, there are some other outputs in terms of students developing their skills and finding good jobs, as their primary objective there, and in the research projects generating some data. And these skills and data also change a lot. What also we found quite challenging and quite exciting as well is to release the prototypes and the software that comes out of this work. So one of the challenges that I had, and I know that many in the academic community have, is that there is a lot of prototype development, and if we want to innovate and find new solutions and do research and development, and not only development and innovation, so there is quite a lot of focus on developing something that doesn't exist, that solves specific challenges, or that allows to run specific studies, experiments, gathering data, proving the point, and then leaving this prototype to rest on somebody's cloud or even a local computer without being released. So this one-at-a-time experiences are quite common in XR specifically, since it's really time-consuming and resource more sort of resource-intensive development to get it to the point where you can release it and share it with the community, both commercializing it or releasing it for free. So this releasing, licensing, and publishing in stores is something that we also try to focus. And this is where we as a lab sort of come in and contribute into because the students don't have the time for it, and the R&D projects don't have usually the resources for that. So this is more or less what I would discuss today at this meetup. And I would name also a few of the practical considerations on this slide, as I show mostly the stuff we encountered running XR lab with, I don't know, dozens of various AR and VR equipment, sensors, cameras, and so on. The problem is there is a challenge of software installations for these kind of labs or computer classes, that IT departments of the university don't know how to manage all this kind of equipment that also you need to update every year or two. Maintenance and repair is also quite challenging. The cleaning became a challenge during the pandemic. There is a challenge on managing the equipment and accounts, especially managing equipment that you don't give to one person to use and develop, but that you want to use for public demonstrations, for example. There are also some Wi-Fi requirements and protected networks, and the university is quite conservative there, and some challenges exist over there, and also software licenses that we need in the development process. And there is another list of considerations on storing and reusing the code using Git for student projects, which relates to ownership and copyright issues. Different universities and in different countries also have different policies on who owns the software code that is written by students, and how they can collaborate with university staff or international partners and projects, and so on. This also relates to evaluation and grading of student projects that are done in collaboration. And there are also content creation challenges on libraries of 3D content, 3D content, cheap 3D content available, but you want to at the same time teach students how to develop content, and at the same time you don't want to create artificial tasks for them, and you want to make it as practical as possible. But when we look at the project needs practically, we usually find the free 3D content, and the students still want to learn how to do it, and this is the never-ending loop. There is also a challenge on publishing distribution of the apps with student contribution, especially if they still own certain parts of the code, and so on. There are various ethical considerations springing out of here. I wanted also to show you one more thing on developing knowledge and building experience in a group in our lab. What we noticed is that since we work so much on various externally funded projects and with many students who come to us usually for a short period of time, from half a year to maybe maximum of 2 years, there is a constantly changing stuff and constantly changing collaborators in projects. This brings a lot of creativity, ideas, a lot of knowledge sharing, and it's quite challenging to keep it. So some work needs to be put into keeping, accumulating experience, and also developing the skills. And we distinguish here into AR and VR development skills and all the related skills to designing and developing experiences, and to user skills, educating our target audiences. And we have some work done on specifically AR, and I just have a couple of the works here on the curriculum for higher education on augmented reality, and also we run continuing education courses for our users, for adults, including some theory on what is AR and VR, what are their application domains, how to work with XR developers, how to procure XR solutions, and then understanding different hardware and then their differences, understanding content, how to work with authoring tools, how to save it, import it, and working with different kinds of files in XR. And also we in this course ask people to make little concept projects on the introduction of XR into their respective domains and organizations. That's my introduction. Thank you.
Thank you, Mikhail. So the last one up is Adel.
Hi, everyone. Let me see. Can you see my screen?
See you? Yes, I can see it. Just put it. Yeah.
Yeah. All right.
Good.
All right. So I'm Adel Qaddoumi. I'm the XR developer at the Center of Innovation at the University of Leiden. I work with Monica and Thomas, our moderators today. So I'll just talk a little bit about the center, and then a little bit how I usually go about developing XR apps before I joined the center, and now even with the work we're doing with the center. So the Center of Innovation is part of the University of Leiden, and we do lots of things with the university and the different faculties. Some of them is focused on learning experiences. Some of it is on data and AI. But now, or for the past 5-6 years, we've been experimenting with XR. We started with 360 videos. That was Thomas' work and a few of our other colleagues. And now most of our projects are with the medical center of the University of Leiden. We can see some of the projects where we started with XR doing 360 videos, and we did it through an open application to the university. So different professors and teachers thought, okay, we can use 360 videos and the different applications. I'm not sure if we have images of them. Yeah, that's one of them. So we had like different experiences to search, for instance, students to see how they interact in labs, or like a kidney transplant, and they see, we recorded the 360 videos of that. And then we had more access to HoloLens, and lots of our applications were using HoloLens 1, and now we're using HoloLens 2. And these are more augmented reality experiences and have more interactions. Most of it have been with the LUMC, and you can see here one of our applications here. This is the what do you call it? MRI, not MRI, CAT scans of the kidney. Here we have an injection application, which was one of the first projects I started working on when I joined the center. This is one of the safety lab safety 360 video. Can you see my mouse? I'm not sure. Yeah. So yeah, we've been working with different faculties, different projects within XR, and it's always challenging when working with XR, and this seminar is about how we can bridge that gap between like the development process of these applications. The thing is, with XR, it's still a very relatively early technology, even though it's been here for like decades. It's only started like being used professionally, or let's say, and being used more. The problem is that the hardware and software are still not there yet. And people have this high expectations of what you can achieve with VR is a little more advanced now, but with AR, it's still very early on. And people have these expectations of what they want to achieve. And it's never the case, because you're always fighting with the hardware or with the software. And although it has advanced a lot in the past 5 years, it's still not there yet. And we still have a long way to go. At least that's my opinion. So before I joined the center, I've worked on lots of different freelance projects with either individuals or agencies. And I've always eventually kind of had this process of how I approach XR projects, because a client would come and was like, I want to create this thing. And then usually they don't have a hardware in mind. They don't have a software development kit in mind. Maybe they would say, oh, I want it to run on the browser, or maybe I want to run it in an app. Maybe I want to run it in this specific hardware. And these things sometimes are predefined by the client or the project itself. And so as a developer, you're restricted to make what they have in mind work on that device and using that specific technologies. And sometimes it's a bit more open. So my approach is always to listen what they're trying to achieve, like really what's underneath. So sometimes it's just they want something that looks shiny, but they're trying to reach a specific educational experience, and doesn't have to use that technology or that hardware. We can achieve the same result in a different thing. So always listen to what the actual requirements are, and then see the technological feasibility of these of the requirement, because I've used like most of the software development kits, like ARKit, ARCore, some of the web stuff, 8th Wall and Zapper, and each one of them has a specific pros and cons. And the only way you can identify which library to use is the project itself and the requirement. So usually after understanding what the project itself is, I research what kind of technologies we can use and give like a summary for the client. It's like, if we go with this approach, we can achieve these things. If we go with this approach, we lose this part. Usually with WebXR, for instance, it's very limited. It doesn't run on iOS, so people have they want to send the link and run an WebXR experience, but it's not possible now, for instance, because iOS is limiting WebXR. So you have to come up with all of this kind of solution, like running on HoloLens 1. It's like developing on HoloLens 1 is hell now, because it's deprecated, but lots of people have paid like 3,000 or 4,000 for it, and then now they're like, oh, we only have HoloLens 1. So always provide like solutions. Okay, these are the paths we can take. Then test them out, build small prototype, and then once you have a prototype, always test with the user, because as a developer or a researcher, someone you have a lot of experience of how to use an XR device, where most people still don't have that experience. It's how people use mobile phones early on. It was still not everyone could use them. And we're at the same stage in XR. So once you test it with users, you immediately identify as like, okay, people are getting lost here. There's some obstacle here with the interaction. And it just like keep going through this loop of like implement a new feature, test it with the user, see if they're getting it. And after that, keep repeating until you have a mature version of the application. And that's usually the approach I take within like developing applications. I think that's it from my side.
Thank you, Adel. All right. I think we're done with the presentations and information overload, which you will all get access to afterwards. But if you have any questions, please do feel free to put them in the chat. And I think what we're going to do now is just go into the panel discussion. And I just want to change it up a little bit. So I want you to channel your inner researcher or your inner developer, because I think I am sort of the person in the middle. I talk to researchers, I talk to developers, and I have a very basic understanding of extended reality. And now I want to know, how can I understand what the developer is talking about? Because like for Adel now, you know, he's talking about all the iOSs and this and that. And I'm like, I have no clue. It's 50% of what he says most of the time, or I have to Google something all the time. And then I'm not sure if the researcher sides have the same problem. So what I want to know is if you could each sort of just give a short description as to the process or workflow that you use when you start a new XR project. How do you want it? Not how the institute that you work for has set it up, but what is your preferred way of working, you know, especially with the people involved? How do you communicate with them? So again, from a researcher's perspective or a developer's perspective. I don't know who wants to take this question first. Any takers? No? Am I going to just put you on the spot? Neil, we haven't heard you for a while. It's your turn.
Okay, yeah, so I typically don't, is why I didn't offer myself there. I don't do that process, but I govern that process, if you like. So I sit at the fulcrum of it. But I run a workshop for people that have got ideas. I've got a template worksheet that I get them to work their way through and answer questions they might not have previously thought about. And I go through a kind of slide at a time, say, this is the things I want you to think about. And then we pause and let them work in a group to fill out a thing, and then progress it through like that. So that's how I do it. I've got a kind of system for doing it, but it's not for my benefits, for other people's.
Okay. Moeezo, from a developer's perspective, how is your workflow? How do you do the process?
Yeah, so we have an agile-ish approach towards project management. It's not very different from what Adel was just describing. We have similarities in our workflow. So our project development workflow consists of 7 different phases. We start with the discovery phase, in which we have our first kickoff meeting with the faculty to discuss their project proposal, their requirements, and then we ask some clarifying questions from a developer's perspective to really determine what would be an appropriate target device or what tools and technologies we should be using to build the project. During discovery, we also prepare flow diagrams and schedule timelines and RACI matrix. And then we have a learning experience designer on our team who works with the faculty to prepare an XR design document, which captures all the learning objectives of the project. And then we move to our next phase, which is pre-production. And in pre-production, we use that XR design document to create a script. And then we write storyboards, mood boards, and we also mock up some UI designs for the experience. And then we start developing some low fidelity prototypes and get early feedback from the faculty. And then we start our production phase, in which we start the actual development of the application within the game engine. And then we begin some quick, we start off with some quick prototypes, and then we get feedback from faculty. And then we keep building upon those prototypes and keep refining them each time. So it's an iterative process till we get we've incorporated all the major features that the faculty requires. So in the production phase, we're working in 2-week sprints, and at the end of each sprint, we send out status reports to the faculty and we list all the major tasks that we've accomplished within that sprint. And then we also send out a demo of the application, or just like a demo video of the major features that we've developed over that sprint. And then towards the end of the production phase, or sometimes whenever it's feasible, we conduct user testing with actual students, and then also perform bug fixing. Then we move to the post-production phase, where we are really polishing some of the features, and then we make sure that the project is optimized for the target platform. And then we export out the final version, which is either an executable for PC-based VR experiences or an APK file for Quest headsets. And we also usually create a desktop-only version for our applications for users who can't access because they don't have the VR equipment that's required, or due to health reasons like motion sickness. So our next phase is distribution, where we deploy these applications to the target devices. So to mass deploy these standalone experiences on headsets like Quest, we've purchased an MDM solution, which is called Arbor XR, which helps us distribute these applications to all of our headsets. Then we've also published some of our applications to the Meta Quest App Lab. And then we move to our launch phase. And here we help out the faculty in using the experience in their classrooms. And we provide the technical support that they would need. And then we also help them conduct some user feedback sessions. And then lastly, our last phase is basically maintenance. And so now the project is being used in classrooms. And then we're just providing them support for critical bug fixes for like a predetermined period of time. Oftentimes it's like 4 to 6 months after the project's been completed that we provide that support. So basically this is like our entire process.
Well, it sounds like you're a lot further than we are in many of the phases. So we're learning from you. Thank you. Mikhail, I also heard you mentioning that you have a sort of agile software approach. It sounds like Moeezo, you use the same sort of agile approach using sprints. So would you like to elaborate?
I don't want to describe the entire process, then I would be repeating a lot. So I can add a few points in addition. So we also use the agile software development methods. But we also, before we can get into agile software development, we start with early stages of the design thinking process, something like the exploration or the emphasize phase. So we work with either the end users or whoever is the subject matter expert or the subject matter partner in the project. So we try to find out from the users what they normally do, and how do they see where in which parts of their normal experience, non-VR or not XR experience, where does XR could come into and what challenges it could solve. And after we go through this process, collect more and learn more about the context and the end users and their challenges, we start working on the design, and some of the points that Adel mentioned there come into the picture, like what sort of devices that would be more suitable, what platforms would be more suitable, choosing between browser experience or application experience, stationary or room setup. Do we need a wireless solution as a prerequisite, and these kind of decisions that the end users often don't realize what's the difference. So what we also try to do, we try to find some examples of related work at this stage and demonstrate, or among our own projects or just among the other existing projects that we could locate and just use as demonstrators of different types of setup, very, very general. And then we try to convey these ideas to the subject matter experts and some representatives of the end users. And then really it can go very quickly if our end users or subject matter experts are somewhat familiar with XR and have at least some experience. And if they don't, this process takes time and effort, but it's important to do it sort of early in the process. In the agile process itself, so we do monthly sprints in most of our projects, or even irregular sprints. It really depends a bit on how many people we can put on the project. So in some of our projects, there's just 1 or 2 people, and then we determine a bit of a more flexible sprint duration, depending on the availability and the time people can put into the project. What is also, I can also highlight one more time with XR, it's really, in our experience, very important to show a very early version of whatever we develop. And then we sort of the gates of the ideas and scenarios of use and requirements starts to pour out from ours as users and subject matter experts, because when you just demonstrate them similar applications or you give them low fidelity prototypes which are flat or non-virtual reality or not augmented reality, their understanding and their creativity is somewhat limited. But when you show them something really simple but made for them in AR or VR, it really triggers their ability to generate, to correct and adjust, and to generate more ideas and requirements.
Yeah, that sounds really, really interesting. Yeah. Adel. Well, Thomas, you've got your hand raised up. Maybe you want to do that first. Sorry, Adel.
Yes, there's a question in the chat from Casper. Casper, you're allowed to ask the question yourself if you want, but I can also ask it on your behalf.
I thought you were going to read it aloud, but no problem. No, it was a question for Adel, maybe. Is it possible to reuse VR, AR applications for different organizations? So you were talking about the whole process of developing these applications, and is it already possible to make more generic models that can be used so that the whole process becomes easier?
What do you mean by a like generic application? What's an example?
So maybe applications that can be used in multiple contexts. So like there's a basis and then you can build on that and you can reuse that in different, so you don't have to start from scratch at every organization. I don't know, I'm not an expert at all.
That wouldn't be the application. So that'd be like the frameworks. So usually when you develop an AR or XR applications, you have lots of layers of software. For instance, Unity you have, and then Unity uses some AR software development kit that gives you like the AR capabilities. And on top of that, you would build some frameworks that you reuse throughout different projects. So for instance, I had to build like a networking library that I'm using in different projects, maybe some. So you do build these things, but as an application where it's used by people, these are very specific, usually very specific case. Maybe you can distribute it to multiple organizations or but the application, and my experience is very specific. I don't know if anybody has a different answer.
Mm-hmm. May I?
Yeah.
So yeah, I can just add a little bit to what Adel replied. So one thing is to reuse an application, and it's a question of any application. I mean, if a commercial company releases a product, they want to sell it to as many people as possible, obviously. And if you are a research lab and you develop an application that either commercially or for free you want to distribute, again, you are by definition interested in more users. The challenge is if you develop the application in a way that it is applicable to multiple users. So maybe you just developed it like here in Norway, we sometimes develop an application in a frame of a locally funded project, and we make it all the interface, all the content is in Norwegian. And then outside of Norway, it's really maybe Swedish and Danish people would understand it, but otherwise you need at least to localize it to different countries. But I can give you a couple more examples. So in a certain way, XR apps are not different from any other software or any other products. But as Adel mentioned, you can build your own platforms and resources that you can reuse. You can make applications that are not for the very narrow niche topic or area. Like, for example, if you're developing an application to learn some anatomy, you can develop it for human anatomy, and then it would be much easier to then build on this and develop an application for animal anatomy or for different anatomical systems of a human and things like that. So that's one possible direction. And the other is to develop more, not the end user applications, but the platforms or content authoring tools, which are a bit lagging behind in the field of XR. There are not so many AR and VR authoring tools, or there are some, but they're at the moment focusing more on very basic AR and very basic VR, such as 360-degree photo, video based platforms, or simple marker based AR and stuff like that.
I see Neil's hand is up. And Neil disappeared.
Sorry, I didn't unmute.
Oh, okay.
Too busy lowering my hand. There's only one button at a time. Yeah, on the trajectory of developing the apps that we did, we always asked our app champions, that's what we called the academics pushing for it, and we asked them at a certain point, does this have to be a canned lesson for one particular purpose, or can we turn this into a tool? And we had various different decision points. So for example, when we were doing one that was about dropping a ball on a ramp for physics, so okay, can we have a slider for how high the ramp is? Or can we have a slider for this or a slider for that? And the more you can put in options there, the wider the use case for the apps in question. Some other ones were about being able to bring in different file types. So for one of them, it was going to be looking at certain specific proteins, but then we asked, well, why can't we just plug into the protein database and get access to hundreds of thousands? So there are kind of decision points we could do there. But one of the efficiencies we got across all of the apps that we had were about UI and UX. So if what we could do is we could come up with good design for what it was like to enter the app, or where the controls or the buttons or the menus went, and keep that consistent, then it would limit the amount of work that you had to do. That was kind of copy paste work across them, but it would also mean any users or any support staff who had to support them had one common knowledge base for across what turned the initially 10 and then a further 16 different applications, and then an overall platform that allowed people to build their own. So that consistency kind of lowered a lot of costs along the way, not just the developer side, but on the delivery side as well. So whilst that's not quite reusing the app in the sense, it is reusing the tools you've got inside maybe one or two apps and then realizing how far you can proliferate them. I think that's roughly what Adel was saying too.
Good.
Thank you.
I'm going to move on to the next section, and it is the question: how do you approach an idea that either you or someone else thought of, where you know it can add value to an educational experience? And what I mean by that is, it could be just a general idea, and maybe there's an XR app that can come out of it, or it could be you already have a workflow where you decide this is best for a VR approach, or an 360 approach, or AR. How do you approach those ideas? Besides, of course, going through the whole innovation fund process, like Moeezo said they were using. Adel.
All right. So there's a difference between developing just XR applications in general and educational XR applications, because now when you have an educational app, it's you have two challenges. One is that you have to teach the user how to use the XR in general, or the app itself, and then you have to teach them also the educational material. And if you fail at the first one, then you're not going to be able to reach the second one. So if you have an app about anatomy and that's the learning outcome that you want from the app, if the user interface is bad and the people are confused and they're frustrated that they cannot change this or move that, then the learning outcome, no matter how the curriculum was of the anatomy application, and in this case, it wouldn't work because people are not being able to access it. So you always have this like two challenges. One is to solve the user experience for XR, which is not an easy challenge. And then you have to kind of build the curricula within kind of a gamified or like a software way of teaching. So now with the application, we're trying to involve educational experts or different learning methodologies. So I eventually am a developer. I don't know these methodologies of learning. So I try to collaborate with people within the university who work and who apply these methodologies, whether on a website or a MOOC or whatever learning material. And we try to incorporate them throughout the development process of the app. So, and then also test it with the students and users, because yeah, that's how you can keep it realistic. Otherwise, it's a bit more hypothetical learning scenario. I don't know, I hope I answered the question.
Well, it's a little bit of a general question, so I just like to leave it open. Neil, you've got your hand raised.
Yeah, I was going to say that when we're thinking about what platforms to use, a very rough rule of thumb, totally defeasible, but a very rough rule of thumb is if it's about an environment, then you should be looking at VR. If it's about an object, you should be looking at AR. And then if it's about interaction and interaction with that, you're probably going to have to be driven by what system has the right controllers or interaction capacity. If touching a screen is fine, one thing. If you need a single controller, a different set of options. If you need two controllers and really good hand tracking, then you need to be in one of the more advanced headsets. But the object environment split is one that is a kind of very rough and ready rule of thumb that I asked them to approach.
Yeah, the other thing you also consider is the reach, because whenever you use a headset, which means your reach is like 10% of what you can use with mobile, or even less. So sometimes that's very important. So if you want a specific application to have really high reach, it's better to do with mobile AR, but the user interactions are really bad with mobile and for XR. And it's better to do it in web XR, because you can just send the link, but also that's even way more limited than mobile AR. So we still have a long way to go, I think.
I can add a couple of points here to the pot of ideas. I think one solution that worked quite well for us is developing as much as possible cross-platform from the very start. So if we study something and we have enough resources, okay, we could plan it potentially for multiple platforms, for the browser, some version for either browser or desktop, for example, and then smart glasses AR plus mobile phone AR. If it's a VR project, then we try to at least cover two different VR platforms. For example, in some projects, we even when the concept and the content fits both AR and VR, we are very happy to make it into an application that works on both AR and VR platforms with different interaction, different maybe some of the features, but same content probably. And in terms of how do we choose or how do we work with a subject matter expert or a client or a partner that comes with the idea of the application. So we usually look at their requirements and we try to get as much information as we can from them. And in the greatest majority of cases, there are limiting factors, and we just end up with having just one or two choices because of either cost limitations or their target audience having that device or being able to use or wanting to use the application in a specific lab in specific settings and so on. So there are usually requirements that help us to just choose one platform.
Yeah, so I can talk about the approach that we use. So whether we typically do like seed funding approach where we're funding the projects and we open up call for proposals. But if faculty is coming to us with ideas or just consulting with us, usually we basically initially approach it more from an academic perspective. So we have the learning experience designers, which have created an XR design document, which helps the learning experience designers and the faculty to start having conversations about the overall purpose of the project and then identify the main learning goals and objectives. And then they identify specific task goals and determine, I'm not too familiar with the process, but it's about identifying those which are conceptual goals, which are more technical goals, and then really identifying what are the specific activities that the users will be doing to accomplish those goals. And then at the end of that design process, you end up with very specific tasks and activities, which you can then use to make a decision whether it's more suited for VR or AR. So basically, in this user learning experience, we are very design process, we're very careful that we're not imposing a technology onto the faculty right from the beginning, but we're taking the time to learn about their goals and objectives and then suggest the technology. So there's actually often a DICE methodology that we talk about. I don't know if you guys are familiar with that, but it's an acronym. So that's developed by Professor Jeremy Bailenson. He teaches at Stanford. So the D stands for difficult or dangerous situations. So XR is best for recreating these difficult and dangerous situations. The I stands for impossible situations. So it's also XR is also suitable for recreating impossible situations that you just can't do in real life. The C stands for counterproductive. So XR can be used to teach an idea through a counterproductive approach. So for example, like one of the examples they use is that if you are letting people cut down trees in VR and see the devastating effects, that actually helps them to not do such a thing in real life when they're seeing what destruction it causes. And then the E stands for expensive. So XR is good for replicating processes that are too expensive or rare to practice in the real world. So these are basically like just some of the ways we approach the ideas. And then after we have all their objectives, then we think about, okay, what's the specific? Is it AR based? Is it VR based?
Thomas.
Yeah, David had a question. I don't know, David, if you want to take the floor.
Yeah, I'll ask the question. It's great. Thank you all for the presentations. A very informative and great discussion. One of the things that I'd like to ask the panel is, over the years, we've switched from one language to another language, from one tool to another tool, etc. And we've had some bitter, bad experience of technologies being end-of-lifed. So things like UDK, the precursor to Unreal Engine. And so recently we've experienced the fallout from the Twitter takeover. And the question I have really is, when you're making a choice for choosing a platform or a technology, how do you minimize the impact or the potential for vendor lock-in, so that you commit to a particular technology or tool and you're stuck with that, whether it's a game engine or even a headset? So I'd just like to hear the thoughts of the panel on that. Thank you.
I can start and give a couple of arguments here. So I already mentioned that we, or not only we, I hear also from others of trying to safeguard themselves developing cross-platform solutions and encapsulating things. And yeah, if one of the platforms becomes more popular than the other, or one becomes unavailable, you still have your software running on one platform, and you would, if there is a new platform becomes available, new device, you would be able to more easily support that device with your software. But more to your question about open source software and solutions, I think XR is still a bit too young to have enough choice of specifically the development tools, and they are all in competition to each other, and there are not so many standards yet that are well established, like the Seaport, so that different commercial or open source platforms use them. So I think we can give this XR field a few more years and it will be easier. But choosing open source now might be a good strategy, very, very long term. But if using a specific vendor or a specific commercial platform is more efficient in the timeline of 1 or 2 years, a lot of people just choose this for a specific project, reaching the goals, delivering, and yeah, I think the horizon of 1 or 2 years is relatively safe, and that's why a lot of people are choosing this, and I think that's also the right choice at the moment.
Anybody else want to add something?
I might say,
yeah.
so,
Go ahead.
yeah, I might say that we have had difficulty on two different fronts here. One is in the kind of move to the controller type that we see from Quest style controllers rather than the previous Vive ones, which some of our early stuff had been developed for, and particularly in the Oculus for Business program being quite as poor as it was, frankly, and then the mothballing of that and then the lack of support for it. And yet I'm going to say the kind of contrary thing here and say we need to go for the best things that are available, and the best things that are available are the likes of the Unreal Engine at the moment for if you want visual fidelity, for example, or Unreal if you want flexibility in how you develop for it. And for the moment, until the open source options are considerably better than they seem to me to be, that is a problem that we want the world to fix, but I'm not sure how we do it. And in the meantime, we need to avail ourselves of the best things going, because it's not like we've got a surfeit of goodwill in this work, in this industry, that we can afford to undershoot. So yeah, I think we're trapped, frankly, and I just hope that the consequences aren't too bad and the open source tools continue to progress. They are progressing, but I don't think they're at the level of the fully fledged tools yet.
Yeah, I can add to the same. It's the technology is still not there, and open source technology is way not there. So if you try like web, for instance, AR and the web, there you have ARJS, which is the only open source maybe SDK, and it's way more basic than the closed source one like Eighth Wall or Zapper. And then you also have different kind of lock-ins. So first you can get locked in the hardware itself. You can also get locked in the engine, as you were saying, like Unreal or Unity. And also each hardware or operating system, let's say, have their own SDK to connect their engine, like the game engine, with the hardware. So you have like these three different lock-ins, and they're all closed sourced for now, unfortunately. There's OpenXR, which is a standard that is being adopted now by Oculus, by HoloLens. So headsets are adopting it. And that makes things a bit more like, yeah, you can move them around and in the future easier.
Yeah, I would just like to add that first, it's an excellent question, and this isn't really something that we focused a lot on. But with Unreal Engine, it's kind of slightly different from Unity. We've done most of our work in Unreal Engine. You do have access to the entire source code. So if you do have the expertise, you could, if there's something you're stuck on and you have the expertise, you can go in and change around and develop new things from that engine. So that's just slightly different. But yes, other than that, yeah, we do oftentimes just lock ourselves into particular technology. That's the challenge we haven't considered much.
Okay. Anybody else still want to comment? Otherwise, I'm going to move on to the last question. No takers? Okay, so the last question, which I'm sure everybody wants to know about, is how do you find funding? Either by us, it's internal. We have a similar system as you have, Moeezo, which is a sort of tiny little innovation fund that we can pitch for. But do all of you have a similar approach? And then also, how do you justify the funding? So the actual funding process, do you have to really focus on the technology that's going to be used? Do you need additional staff that you need to hire if it's a bigger project, or even put funding towards developing the skills? So it's kind of, the question is, how do you find it, and how do you sort of separate where the funds are really being allocated? Who would like to go first? Moeezo, you there?
I was going to say, I'll maybe say something, but you can go, Moeezo.
Yeah, so I cannot speak a lot about how to utilize those funds, because we've mostly been part of the people providing the funding. We have divided some of our funding into in-kind support that we as developers provide, and then support for buying the equipment and software. But in terms of, I can speak a little bit about the successes that we've had with finding funding for our own center. So, so we have the apart from our internal funding, where we are sourcing projects from the faculty, we've had success with applying for the EPIC Mega Grant, which is available on a rolling basis, and we won this EPIC Mega Grant about a year and a half ago to teach our to hire more students, fellows to work with us, and to teach them how to build VR applications using the Unreal Engine. And then we've applied for, but we're not very successful with that. But I would encourage you guys to explore that Unity for Humanity grant is also available for educational purposes. And then Meta also has funding opportunities. And then one of our suggestion would be to just network with your local groups that work for local communities. We were able to get some funding for hiring more students to work with us through Spark, which is a local economic development group that supports startups and local companies within Ann Arbor. And we've also had success in just talking to different vendors about what we do, explaining how we support educational technology, and then they're just willing to support us with our cause, really. So we've talked to HP and Lenovo, and they've donated us some very expensive equipment, including their high-end VR headsets, laptops, and computers. So yeah, these are just some of the things that we've explored, and they're available for educators to just apply for these grants.
Thank you. Neil.
Yeah, the most work we've been able to do has been from UK government grants, but not through the normal research path. So not through like the Arts and Humanities Research Council or whatever, but actually through Innovate UK, which is the innovation funding from the government. And that required, as my little presentation probably implied, that we had to think through business cases and think through what economic impact things would have. We're hoping for another round of funding in a very large sort in January if we're lucky. Our funding has to come externally for that at the moment. My next plan, and the one I hope that one of our projects will inspire the university to support, is I've been asking for funding for an internal content creation team, so internal software development and internal 3D art work, because I think our university has got enough use cases for it to merit that, but that's an expensive and ongoing facility to offer, and they're as yet unconvinced of the merits of it. So I'm hoping that that's how we'll end up doing it in the future, to stop us having to spend as much friction time, A, going and sourcing the funding, and then B, on the procurement of it. If we can do stuff internally, I think that will unshackle teachers and researchers quite significantly. It's just expensive and hard to persuade university management to go for the moment.
David, your hand is up.
Just want to ask Neil, just on that very point, if I may, where do you think such a unit should reside? Should it be in the IT group? Should it be in the learning technologies group? Should it be in the in a particular school? Because I'm facing exactly the same problem, and I don't know where to put this group.
Yeah, none of the above, I think, is the answer. I think it needs to sit with. I think it needs to sit within a kind of cross-university XR unit. That's what I have. I think successfully the last bit of how we manage it and locate it is up for grabs. But I've managed to get a pot of money and a support system that is pan-university, so across all schools, colleges, and across research and teaching functions. So that's where I said it had to sit, because one of the things that we quite often do is buy one set of headsets in here on the budget that's actually for research, but swap it with the ones for teaching, because that's the best overall fit. And to be able to think holistically about that and strategically about that, the software that you invest in, the hardware you invest in, and the skills of the support staff, thinking of it as divided between research and teaching is inefficient in my view. And to do it school or college by college, you'll never find enough resource sitting in one place at one time in order to do it. Or at least if you do, the arts and humanities will get nothing. So that's why I've been trying to pitch things pan-university, and it depends on your institution where that then gets to sit, but sort of university services or something is the category that our institution found for that. It's very, very difficult. That was one of the biggest challenges I found, though, is finding the right slot.
Very difficult indeed. I'm actually currently looking at maybe positioning it in the library, as a shared resource that cuts across all the colleges, etc. Yeah. Very interesting to hear that.
Institutionally that didn't work because of some physical assets that we had that couldn't belong to the library, but it was a live option, and that very well might work elsewhere. Yeah.
Thomas, you have a question?
Yeah, I think a lot of time when people talk about funding, they want to start, the project like the first pilot, or maybe like they see this project as a thing that they can finish. But a lot of people don't realize that there's a very long tail of maintenance and ongoing development. Well, that's more optional, but at least the maintenance is actually always there. And a lot of the times, no one gives that a second thought. It's just not on their radar. Which is a shame, because then you see these apps that we've developed sort of lapse and kind of fall by the wayside because the devices are broken, or they can't invest in new ones because the old ones aren't maintained anymore, or anything like a continued development, stuff like that's just not factored in. And I was just wondering, well, first of all, what are your thoughts about this? And also, do you include this in project funding or project development in general?
I can add a few thoughts on top. I have exactly the same challenge as number one challenge that I try to solve in my immersive tech lab and in university. And I'm really thinking that those people who are thinking where to position such a XR development in a university, if you can have a choice, then you have a luxury problem, because we have been put here without anybody asking us, and nobody here in the institution where we are in understands not only that you need to maintain things, but you need to also develop things. So the faculty we are in is much more into integrating the XR into different courses and teaching, in supporting people doing research, but development of new tools is really out of the scope, and we do it as a means to do research and as production of the results that can be integrated into and support teaching. And maintenance is really hard. So most of our funding comes from, I don't know, dozens of projects, and each project lives its own life. It has its own objectives, but I mean, to be able to get on board 10 projects in 3 years and develop expertise and develop a network, that is, I think, much more challenging and much less or much more difficult to get support and to get funding for. And I don't know how to get it. And if somebody has a solution, please share.
No solutions out there? I definitely don't have any, unfortunately. Not yet, anyway. I'm wondering if it's if we're all in the same situation, where XR is still a new thing and the way it's being dealt with is exactly the same in the same situation. Thomas?
Well, I was thinking about this because looking back at the things I've developed in the past, I see that many of them are simply no longer being used, which is a shame. But maybe, maybe you should think as in terms of life cycles, right? So we already do this for other projects. So for some reason, because it was a pilot trajectory, we didn't include it in the project funding. But if you have a life cycle, you also know when it's going to end. So you can plan for that. And you can also say, okay, at this point, we're going to have a conversation about continued funding if you want to continue to use this app. So in that case, it's less of a shame maybe if an app that you have developed with a lot of love and effort gets sort of stopped because apparently there wasn't enough interest or financial, to finance it continually. And yeah, that is probably inherent in developing XR apps. They are continually developing, there are new headsets. So what was sexy 3 years ago is probably not so interesting now. Maybe not.
Okay, so this was the last question. If anybody still wants to say anything, please raise your hand or put it in the chat. And otherwise, the floor is for Sally to close off our session.
Thank you so much, Monica, and everybody else as well. It's been really, really interesting. I'm just having kind of a private conversation with David. I think that whole question about where you place these facilities in university is such a tricky thing to deal with. We've seen it right the way across the board in other areas where we work about AV centres and development centres. But anyway, it's a common problem, I think, for everybody. Look, just before I show you a couple of quick final slides to close out the session, is to say that we're really keen to develop our network of expertise within the association together with XR ERA on the topic of XR. So we will be looking in spring at putting together more sessions online. We're having one in April, for example, on medical applications in XR, and we'd like to build the community around this as best we can. So if you have ideas for us or suggestions for how a small little organization like us that's busy at a European level can maybe support the networking and knowledge exchange, please feel free to contact us. We'd love to hear from you. So we want to put up a couple of quick slides, a couple of reminders, which Dovie has ready for me. Just to say that indeed we have, these are our upcoming media learning seminars. The one, the 15th December, is coming from our transaction project about sharing knowledge and resources generally on media supported learning. So we want to tell you what we're doing in that project and share with you the work of our partners. Then in January, we're going to look at podcasting, but specifically about how universities support podcasting. What are the kinds of services that they put in place to support podcasting across the campus and outside the campus, of course, as well. On the 23rd of February, then we're going to do a follow-up to a session we did last year very popularly, which is a virtual tour of advanced learning spaces. So if you have a learning space that you'd like to show us around on one of these Zoom calls, we'd love to hear from you. 30th of March, we're going to look at the reuse of large quantities of video resources. Many of our members have tons and tons of video resources these days, and it's interesting to share experience on managing, archiving, reusing these kinds of resources. So that's what we're going to do in March. Then in April, as I mentioned, we're going to talk about medical applications in XR. So this is a real shout out to those of you that are busy in that area. If you'd like to talk about that, we'd love to get some exchange and some sharing maybe of resources. And then in May, we're going to talk about AI, ensuring privacy and anonymization, which is a topic which, again, many of our members and the wider community are kind of grappling with these days. In June, we'll have our conference in Leuven. Stay tuned to our newsletter for more information about the face-to-face conference when we will be featuring XR in a big way. And I hope we'll have lots and lots of demos and talk about some of the platforms that you're talking about today. We want to try and foster this collaboration between the developers and universities and people who are developing, and also the companies that are supplying, particularly the startups that are busy in this area. Even if they don't last very long, at least in terms of the skills that are developed, are really important going forward. The next slide, I think, is just to say thanks. Thank you very much to everybody this afternoon.